No one expected Elon Musk's denial of the X to be the trigger for Tesla's quieter, bolder game-changer. When Reuters reported that the company's popular car project had been cancelled, the world briefly believed Tesla had backed down. But the response came quietly, not with words, but with deeds. While competitors laughed, production lines in Nevada and Texas were getting new structures. And in Europe, the Berlin Gigafactory's factory floor picked up a frenetic pace. It was as if Elon was saying, "Believe what you see, not what you read." And what the world saw was the birth of something much bigger than just a cheap car. Even without mentioning the name Model 2, the puzzle was coming together with very obvious pieces. Heavy investment in compact vehicle engineering, the arrival of strategic suppliers, and the mass hiring of engineers for smaller platforms made it clear. Tesla didn't just have a plan, it was quietly executing it. Meanwhile, the Asian market, especially the Chinese market, which dominated the affordable electric vehicle market, was beginning to stir. Beijing knew something was coming, and it wasn't just rumors. Instead of a pompous press conference or neon-lit teasers, Tesla got straight to the point. It expanded factories, signed contracts, and let strategic leaks show that the so-called cancellation never happened. Instead of inflating expectations with empty promises, the company built its response with concrete and steel. A strategy very reminiscent of Elon himself, averse to frills, obsessed with execution. Meanwhile, the international landscape was beginning to shift. Markets like India and Europe were preparing for the arrival of new Tesla dealerships, and with them, a model that promised to break the rules. The key move was precisely how Tesla positioned itself. Not to compete with China's entry-level electric cars, but to surpass them technically and logistically. A popular car can't just be cheap. It needs to be durable, easy to maintain, and compatible with the energy realities of different countries. And that's where Tesla was betting, on mass production, with radical efficiency, innovative technology, and less dependence on imported components. The goal was to deliver a car under $10,000 with Tesla DNA, not a watered-down copy. Gigafactory Texas, for example, is being adapted to house more compact and integrated assembly lines. There, the focus is on vertical production, where almost everything is made in-house, from the battery cells to the vehicle's structural parts. This ensures quality control, agility in adjustments, and a significant reduction in unit costs. Meanwhile, in Nevada, the battery plant has been restructured to manufacture a new generation of cells that promise to be smaller, cheaper, and even more efficient. All this without relying on Chinese lithium. In Europe, the Berlin Gigafactory has gained a strategic role. Tesla knows that European consumers value not only price, but also energy efficiency, carbon footprint, and compact urban solutions. Producing the car in Germany means serving this audience with a local product, avoiding tariffs and meeting the world's most stringent environmental regulations. And it is precisely this cluster of factories in the US, Europe, and eventually Asia that supports the thesis that the Model 2 is not just a promise, it is already being shaped. Another clear indication lies in the production pace of undisclosed prototypes. Supply chain sources indicate that Tesla's suppliers of plastic parts, connectors, drivetrains, and modular structures have received orders that are unusual in scale and specificity. These orders are consistent with a smaller, lighter, and faster assembly car. Cross-referencing this data with recent customs and patent filings suggests the project is already in the pre-production phase. Deep down, the question hanging in the air was, why so much secrecy? And the answer is simpler than it seems. Elon Musk knows that the Model 2, if announced too early, could cannibalize sales of other models, or even give competitors time to react. Holding back the name, design, and details until the right moment is a war tactic. And this war is against a powerful enemy, China's dominance of cheap street cars. But the tide has turned. And Tesla, is about to make its move. What seemed like a mere technical tweak turned out to be a true, silent revolution under the hood of Tesla's future most affordable car. Replacing traditional radial flux motors with the new, unprecedented axial flux motors was more than a mechanical choice. It was a strategic, game-changing move. This technology, previously restricted to niche applications like electric motorcycles and supercars, is about to reach the general public with the Model 2. And the reason behind this lies in the brutal efficiency this motor offers. While conventional motors convert electrical energy into torque with considerable losses, the axial flux motor does so with 30% less waste. This means faster acceleration, lower fuel consumption, and a driving experience that promises to become a benchmark among compact electric vehicles. Instead of the elongated cylindrical shape found in the Model 3 or the Model Y, the axial flux has a flattened, disc-like structure. This geometry isn't just aesthetic. It allows the magnetic field to work more directly along the axis, delivering torque with greater precision. For those who live in urban traffic, where stopping and starting are constant, this translates into responsiveness and unprecedented comfort for this price range. But the most curious thing is that, with this change, Tesla achieved something rare, increasing power while simultaneously saving physical space inside the car. The axial flux motor is about 80 to 100 millimeters thick, half the size of conventional models. This increased volume freed up 70 to 100 liters in the vehicle's interior design. And when it comes to a compact car, every inch counts. Tesla used this clearance to lower the center of gravity by up to 15 millimeters, which improves cornering stability and makes the car safer and more fun to drive. Furthermore, this extra space allows for a larger trunk and improved rear seat comfort, two aspects that are often sacrificed in entry-level models. Another technical detail that goes unnoticed but makes a huge difference in practice is how this motor handles heat. The disc design distributes heat much more evenly, avoiding the dreaded hot spots that often cause performance loss. Tesla estimates that this system reduces critical temperature zones by up to 25%, meaning less wear and tear over time and stable performance even on extremely hot days. For those who live in regions like Texas or northeast Brazil, this is a game changer, and it doesn't stop there. Since torque increases with the cube of the rotor diameter, simply increasing this measurement slightly multiplies the force delivered to the wheels. A 300 mm rotor, for example, can generate over 500 Nm of torque, something only seen in dual-motor vehicles. And all this with just one unit. This feature allows the Model 2 to deliver performance that rivals much more expensive models, even with a simpler mechanical setup. The secret lies in the balance between innovation and efficiency. Beyond performance, the new engine brings direct benefits to acoustic comfort. It vibrates less and emits up to 30% less noise than conventional engines. This reduces cabin noise by up to 5 decibels, something that typically requires additional sound insulation or expensive solutions. In the Model 2, the silence comes from the engine itself. This not only improves the driving experience, but also transforms the interior environment into something more sophisticated, even on a tight budget. Long-term savings also factor into this equation. With 25% to 40% fewer moving parts, the axial flux motor significantly reduces friction and failure points. Items like internal bearings and seals, which often fail over time, simply disappear or have their function simplified. This cuts maintenance costs, extends lifespan, and reduces the owner's budget by up to $1,000 over 8 years, according to Tesla's own estimates. For a popular vehicle, this kind of advantage can be decisive. Ultimately, what's striking is how Tesla managed to transform a technical decision into a strategic asset. The axial flux isn't just a piece of advanced engineering, it's a key that unlocks several doors at once: performance, economy, comfort, and scalability. And by betting on this change in its cheapest car, The company sends a clear message to the market. You don't have to sacrifice quality to be affordable. This engine overhaul is just the beginning of what's to come. The heart of an electric car isn't just the engine, it's the battery. And in the case of the Model 2, what's about to happen borders on the unbelievable. Tesla has developed a battery that goes far beyond traditional lithium. It's a combination of graphene and quantum dots called Quantum-Enhanced Graphene 2680. This complicated name hides an advancement that can double battery life, cut costs by up to 65%, and even enable lightning-fast charging from 0 to 80% in just 6 minutes. But the most surprising thing is that it was designed to be small, light, inexpensive, and integrated directly into the car's structure. In other words, it stops being a component and becomes part of the vehicle's skeleton. This new cell, sized 2680, smaller than the famous 4680, has two crucial advantages. First, it takes up less space, which is perfect for compact cars. Second, it allows for more flexible arrangements within the body. This means Tesla can strategically distribute the cells within the chassis, improving safety, balancing weight, and freeing up space in the cabin and trunk. This flexibility also reduces production waste because the assembly adapts more efficiently to the molds and materials used. The result? Simpler manufacturing, with fewer steps and lower costs. Graphene is the driving force behind this revolution. Because it's hundreds of times more conductive than copper and extremely thin, it allows electric current to flow almost instantaneously. But it's the addition of quantum dots that transforms this battery into something truly intelligent. These dots can detect minimal temperature variations and react in real time, precisely controlling energy flow. This prevents overheating, premature wear, and, most importantly, explosions or thermal failures, one of the biggest risks in today's batteries. More than just protecting, these quantum dots learn. Over time, the battery observes the driver's habits, where they recharge, how often they accelerate, how they behave on long trips. Based on this data, it optimizes energy use and adjusts its own cooling. This means that, over time, the battery's efficiency improves, something unthinkable in current models. Instead of losing performance with use, the Model 2 can even gain real-world range over the months. Another distinguishing feature is modular replacement capability. If a cell fails, it can be replaced individually without compromising the rest of the system. This reduces maintenance costs and facilitates repairs in regions with less technical infrastructure. Furthermore, the new cell remains stable even at temperatures above 40 degrees, making the car ideal for hot climates without the need for complex cooling systems. In locations like Brazil, India, or the southern US, this represents a huge advantage. The car's structure also benefits. Instead of installing a battery pack under the floor, as in the Model 3 and Y, the Model 2 integrates the cells directly into the vehicle's structure. This increases chassis rigidity by up to 40% and reduces overall weight by about 30%. With less mass to push, the car accelerates faster, brakes more efficiently, and consumes less energy. All this without sacrificing safety. In the event of a collision, the structure with integrated batteries helps absorb the impact, protecting occupants. This structural integration also contributes to the quietness of the cabin. Because vibration is better distributed, interior noise is reduced. At the same time, the strategic arrangement of the cells allows the sound and climate systems to operate with less electromagnetic interference. The experience for the driver and passengers is therefore more comfortable, cleaner, and more immersive, without the need for technological tricks or manual adjustments. But perhaps the most direct impact will be on your wallet. This battery is estimated to represent only 22% of the Model 2's total cost, compared to 40% for current models. This is only possible because Tesla eliminated expensive materials and complex processes, opting for a simpler, smarter solution. The end result? A car costing under $10,000 with superior range, virtually zero maintenance, and a battery with an estimated lifespan of 1 million miles. What once seemed like science fiction is about to roll off the assembly line. While other automakers still compete to have the biggest dashboard or the flashiest software, Tesla has decided to take a very different path with the Model 2, one of quiet intelligence. No flashing lights, chatty assistants, or features that only impress in the showroom. The focus here is different, making the car smarter in what really matters, making the driver's daily life easier. This philosophy has even earned an internal name, Smart Living. And, contrary to what the name suggests, this isn't a car that needs to be constantly connected to the internet. It learns from its owner, optimizes routes, saves energy, and takes care of its own health without attracting attention. Within the first few days, the car begins observing the driver's patterns. It understands what time the driver usually leaves, which routes are most used, and where they usually recharge. Within 2 weeks, the system can suggest the most efficient route based on real-time traffic data and charging station locations. All of this is cross-referenced with a database of over 50 million vehicles. The idea is simple: to make the driver spend less time and energy without having to press any buttons. It's the car that thinks for itself. But this intelligence doesn't stop at the commute. The system also monitors local energy rates and reschedules charging times for cheaper periods. In places like California or Texas, where electricity prices vary up to 40% between peak and off-peak times, this can generate savings of up to $300 per year. And for those with smart home systems, the car communicates with the home network and schedules charging at the exact moment when energy is cheapest. No complicated apps, no voice commands. It just does it. Beyond fuel savings, the Model 2 also works to avoid unpleasant surprises. The car monitors over 120 different components and can predict failures before they occur. A bearing starting to wear, a sensor that might fail in the next few days? The car warns you. This predictive maintenance system, inspired by aerospace technologies, reduces the chances of unexpected breakdowns by up to 70%. It's not just a cool feature. It ensures the driver will get to work without being left stranded along the way. Another detail that seems small but completely changes the user experience is the intelligent climate control. Instead of turning on the air conditioning or heater every time you get in the car, the Model 2 automatically adjusts the climate according to the weather forecast and the driver's taste. When it's too hot, it avoids wasting energy on unnecessary cooling while the car is parked. This helps preserve battery life and also improves comfort on short daily trips. A touch of intelligence that goes unnoticed until you realize you never had to touch the climate control again. And there's also family mode, which recognizes who's driving before even starting the car. With seat sensors and personalized keys, the car understands whether it's a parent, child, or child behind the wheel. In seconds, it adjusts the mirrors, seat,